Hey, welcome back to my lab here. I wanted to do a short video on this new gear I had recently acquired from eBay. This is a decade resistor, and it's made by this company called General Radio Company, and the model number is type 1434-G, and the serial is 405. That looks like an I. This is a variable resistor stack, if you will, and it goes all the way to the far right here. Let me see if I can get you a shot. It goes all the way from 0.1 ohm steps to 1 ohm to 10 ohms to 100 ohms to 1k ohms to 10k ohms and up to 100k ohm steps. So you could do up to, let's say, 1 meg point 1.999 megs. So I have been eyeing this gear for quite some time. They come in various stepping stack. Some go up to 100 megs. They're quite expensive. For what I'm trying to do, 1 meg seems like a reasonable spec for my lab. These are made quite uniquely. I mean, when you open the box, you can tell just to maintain the accuracy and the tolerance. The way these resistors are made, or the variable resistors are made, is by winding copper wire around sort of a ceramic type of a material, thereby attaining resistance depending on what you choose, etc. So if you recall, old school rheostat variable resistors we used to have in our physics labs or whatever, kind of resembles something similar to that. In any case, so I thought I'd do a short test on this gear using my digital meter made by Siglent. Let's see if I can get a close-up of that. Right there. And I'm going to set this up and see if I can get this going here shortly, and I'll be right back. Okay, so the way I've set up the digital meter is on a relative mode, and currently the range is set to auto, and it's hooked up to the decade resistor box here. All of these values are set to 0 at the moment, and the value is reading as 0 ohms. So the point of this is to see how accurate this unit is. In any case, my goal here is not to go analysis paralysis, but rather say, hey, is this box good enough for my lab? Really, that's it. All right, so let's go. I'm going to start with the far right here, and it's hard to kind of capture both this box or this section here in the meter. So I'll do my best to see how I can capture both in a frame. If not, I will try to zoom in when needed. All right, let's go to 1. This is 0.1 ohms, and as you can tell, it is showing 0.1 ohms. And let's go to, so that seems like good, accurate value, given there are only 2 decimal places here. Let's go to next. It shows 0.21. I've seen this these boxes kind of fluctuate over time. Um, Again, the resonance kind of changes with time, perhaps heat and temperature, number of amps that run through the circuit box makes a difference. So any case, right now it's showing 0.21. That seems like pretty accurate to me, at least for what I'm trying to do. Let's go to next. 0.33. Next. This is 0.4, although that's quite a bit bigger delta than what I was hoping for. Let's go to, so it looks like 0.4 might be a problem here. Let's go to next one. 0.5, I thought this was, hang on, let's go back to 0.4. That's more like, let's go to 0.3. 0.2. 0.2 is good. 0.3 is good. So as you can tell, it does fluctuate. So this is not a digital decade resistor. So let's be clear there. So there's some, looks like there's some wiggle room going on here. So let's go to 0.4. It shows 0.46. Let's go to next. 0.5, 0.49, 0.5 fluctuation. That looks okay. 0.67, 0.66. Again, this is one of those over time maybe. 0.70 looks pretty good. I think it's quite challenging, especially you're in that lower end of the resistor bracket, right? There's quite a bit of fluctuation and inaccuracies, if you will. This is 0.8 ohms. It's showing as 0.97. Again, there's quite a big delta there. Let's go to 0.9, 0.91 for 0.9 reading. That's pretty good. Now let's go to, this would be 1 ohm, although that's showing as 1.6, which is not accurate. So let's go to 1 again. One more thing, I think I've noticed this is quite an old gear. This must be in the 80s, 70s, 80s, if I'm not mistaken. What happens over time is obviously these variable resistor knobs here, they're mechanical knobs. So there's some level of a contact happens inside of the box, and over time those contacts need collect dust and whatever around those conductors. So this can definitely use some cleaning, just so we are on the same page. So perhaps once we do the cleaning, this can get much better from a so as you can tell, when I wiggle this, it gets better there. It's 1 ohm now. So I bet if we do some cleaning on these the contacts on these these resistors, the variable resistors or the knobs, I think this will get really better. For now, as you can tell, now it's showing 1 ohm, which is pretty accurate, right on the nail. All right, so let's go back to 0. All right, so now we're done with the 0.1 ohms. Let's go to the 1 ohm range. Again, it shows 0.99. I wonder if the wiggle helps a little. Again, this might also require some cleaning, I bet. See, that's 1 ohm. Pretty good. Let's go to 2 ohms. 1.99, Pretty good. Again, this could be some cleaning situation going on. Okay, 1.9. I'll take that for 2. Let's go to 3 ohms, 2.99. All right, let's go to 4 ohms, 3.99. So that's pretty consistent. It looks like the 0.01 tolerance seems like a reasonable wiggle room there. So 0.5, or rather 5 ohms, 6 ohms, 7 ohms. So I bet once I clean this machine, this will get much better. Okay, anyways, 7 ohms, 8 ohms, 9, 10 ohms. I think this one here is consistently performing, even though it's 0.01 delta. This is still performing consistently with that delta across the dial, which is good. All right, so I'm gonna switch this back to 0. Let's move to the 10 ohm range. 9.99 ohms, 19.99 ohms. This looks good. 30 ohms, 40 ohms, 50 ohms. So there we go. 50 ohms is right on the nail. Well, maybe not. 60 ohms, 70, 80, 90 ohms, right? That's 100 ohms. Pretty good. I mean, to get that level of accuracy with your, if you were to build something like this, like a resistor network for your circuit, to get that level of accuracy is quite challenging, as we know. Let's move to the 100 ohm range here. That would be, so one other thing I'd like to call out is, if you look in, let me actually get this close up. So the range is set to auto, and it picked auto for 600 ohms. So that range, I'm hoping, will automatically change to factor in the range of resistance we are going to be working with in this category of dial. So let's go back here. So 100 ohms, we are in 0. Let's go to 100 ohms, 99.98 it says. 99.99. Okay, again we are seeing a 0.1 tolerance, 0.01 tolerance that is, sorry. 200 ohms, 300. For this one is unique. It's actually, the delta is on the positive side. 300. Yeah. I think the 400 one has a 0.01 on the positive delta, which is, again, I think once I do a cleaning on the inside, I'm hoping this will get really good. I'm hoping. 500 ohm, that's right on the nail. 600, this has a similar 0.01. 700, this is kind of under. Oh, hang on. Oh, I see. You know, okay, the reason why it's showing 0.799, the range switched to, here, let me make sure you guys are able to see it. This is important. I mean, once you hook up your digital meter, just to keep an eye. So now the range used to be in the 600 ohm range. Now it switched itself to a 6K ohm range. So obviously when we did the 800 ohms on the decade resistor, because the range is 6K ohm, it's 0.79, which is again quite good. All right, I just want to make sure you guys saw that. Switch it back. All right, so 800, and then we got, let's move to 900. 8, yeah, that's accurate. Again, a 0.01 delta. This is 100 times 1K. This is 1K resistance, right? So again, there's a 0.01 delta there. All right, I'm gonna switch this back to 0. All right. Okay, let's move to 1K steps. We are on 0. Let's switch to 1K. So the range is 1.0001. Again, that's a totally acceptable accuracy for me. 2K, 3K, wow, this has a little bit more delta. 2K, 1K, 2K. Yeah, I bet if I cleaned that, that'll take care of it. 3, 4K, 5K, 6K, 7, 8K, that's right on the nail. 9K is right on the nail. 10K, right on the nail. Perfect. So I'm gonna change this back to 0. Let's move on to 10K steps here. 0, 10K. By the way, the range changed to 60K ohm range. I won't zoom in, but trust me, it's on 60K ohm range. So it's right on the money. 10K, 20K, there's some delta there. 30K, 40K, 50, 60, 70, 80. 80 is right on the nail. 90K on the nail. 100K on the nail. Again, if I had more decimal accuracy meter, this you might see some additional whatever, right? But again, keep in mind, these wires here can also add some resistance to the overarching test setup here, right? All right, I'm gonna switch this back to 0. All right. 0. Now we are moving to the last one here, the 100K range. 100K, 100K, right on the nail. 200K, fluctuating a little, but yeah, that's good. 300K, 400K. Again, if I wiggle this, it kind of fluctuates. 400K, 500K. I mean, to get that level of accuracy just in and of itself for what I'm trying to do is pretty good. 600K. Nice. 700K. 800. So now it changed. The range has changed to 6 meg ohm range. So we're in the 800 megs right now. 900 megs. Rather 900K, my apologies. This was 800K, 900K, that's 1 meg. That's pretty good. Now I wonder, let's leave that 1 meg as is. I'm gonna move to this 100K dial. I'm gonna change this to 1.1 meg. I'm going to change the 1K dial to 1.11 meg. 100 ohm dial to, that's pretty accurate, 10 ohm to 10 ohms there, or 1K close to, or 100K. Change that to, what is that, 10K, 1K. That's pretty good. So it's 1.1111 meg. That's pretty good. All right, thanks for watching. I'm gonna maybe see if I can spend some time in cleaning. I know they sell, I forget what the brand is called now. They sell this canister cleaning liquid that's meant for vintage electronics or vintage audio, hi-fi audio sort of gear. I'm gonna see where I can get one of those and see if I can get this cleaned up, and then we'll do another test if I can after I clean it up. Thanks for watching. Hope this was useful, and we'll talk soon. God bless. Bye.